Hello and welcome back everyone. This is Noah, and in this video we're going to look at converting a quadratic function to vertex form when its leading coefficient is 1. Alright, the examples we're going to look at, the instructions say given the following quadratic functions that are given in standard form, we want to convert these to vertex form. So I'm going to create a little bit more space for myself here. That should probably be fine. The first example we're going to look at is f of x equals x squared minus 14x plus 52. And this is going to be a little bit different from when we were solving an equation by completing the square, but we are definitely going to be completing the square here. What I want to do is I want to focus in on just these first two terms. I'm going to ignore the 52 for most of the problem here. So I'm going to complete the square on just these first two terms. All right, so write that down. So how we're going to do this is I'm going to give myself a little bit of room, and we're going to realize that if I want to create a perfect square out of this, I'm going to need x minus 7 squared right here. And we're going to have some other stuff that comes into play here, but why do we want an x minus 7? How do I know that it has to be a 7? Well, this has to be half of the 14, so that when I multiply x minus 7 times x minus 7, not that we need to do this for this problem, but to show why this works, if we FOIL this out, we want to end up with a minus 14 in the middle. So we get an x times x is x squared, and then a minus 7x, and then we'll get another minus 7x, and then we'll get a plus 49 when we FOIL all of this out. And we want these two to add up to negative 14x, which they do now. So we need that, since it's the same thing, it has to be half of whatever that middle term's coefficient is. So it's a minus 14, so we need it to be a minus 7 inside that square. But there's a consequence to doing this. When we create this perfect square, we also end up with this plus 49 on the right there. Actually, this is half of that minus 14 is minus 7. So we just added 49 to this, and so if we want to keep that without that, right, so that just added 49 here, I also need to subtract 49 to keep everything in balance. So I subtract a 49 to make up for the fact that this had a consequential 49 getting added to everything when we created that perfect square. And then the plus 52 will come down. And then we can go ahead and just add up the minus 49 and the plus 52. If you're feeling really confident on that, you can kind of skip that step and just add those right away there. But I want to go slow here and make sure we're all seeing how this is working out. And that's it. This is now in vertex form. We can see the vertex is 7, 3, and the a value is 1. And that's all we're going for right now. So we just want to start completing the square in order to put these into vertex form. So I know that we use completing the square to solve some quadratic equations and also to prove the quadratic formula. And now we're using it to convert a function from its standard form. At the beginning, this was the standard form. ax squared plus bx plus c. And now we're in the vertex form. And as a review, that's a times x minus h squared plus k. Cool. All right, let's do another example here. Let's do a couple more examples. Part B, squared plus 8x minus 12. So I like giving myself a little bit of space here, and then I'm going to open up a parentheses, and I'm going to put x, and this is going to be half of positive 8 will be a plus 4, and then we square that. Now, if we FOIL that out, then this will give us x squared plus 4x plus 4x again. It's also going to add a 16 to everything. So this added 16, so I need to take away 16 as well to balance that out, to make up for the fact that that x plus 4 squared added 16 to the problem. That minus 12 is just coming down there. And then we go ahead and add the minus 16 and the minus 12 together to get minus 28. That's it. We're done. So this really isn't that bad once you get comfortable with it. It's that process of being okay with saying, okay, this added 16 and I need to keep the problem in balance, right? I can't change the expression. So I don't have an equation. I'm not solving. I can't do the same thing to both sides. I'm not trying to do the same thing to both sides. I'm just trying to change the form of this side. So if I do something that has the consequence of adding 16 to it, I have to take 16 away so that everything stays in balance. I feel like I'm repeating myself and not necessarily. Continue seeing this pattern of how this works, but they're going to get a little bit trickier here. The minus 5 is not an even number, so when we do this, it's going to be, we're going to end up with fractions. So I want to find a perfect square. I'm just looking at the first two terms, and so this is going to be an x minus half of 5 is just 5 over 2. 5 divided by 2 is half of 5. And this is a square. And then we need to say, okay, if we FOILed this, we would end up with a 25 over 4 as a consequence. We just added 25 over 4 as a consequence of squaring that 5 halves. So again, I'll show this. This is not a necessary step, but we just, that's that number squared. So we go half here, and then we go square that number to get that. Then we need to take 25 over 4 away to keep everything in balance. And I'll bring down the plus 2. Sorry, I said I was going to FOIL this out to show it. When we FOIL this out, this is x squared, and we get a minus 5 halves x, and a minus 5 halves x. We get a plus 5 halves times 5 halves is 25 over 4. This is x squared minus 5 halves is minus 5. X. It's minus 10 over 2, which is minus 5, and then plus 25 over 4. So we need to subtract the 25 over 4. Oops, typo there. 25 over 4 to keep everything in balance. And then I need to get, combine the minus 25 over 4 and the plus 2. So minus 25 over 4 plus 2. If I get a common denominator, minus 25 over 4, and then we need a plus something over 4. So that 2 is over a 1. I multiply top and bottom by 4 to get 8 over 4 there. Negative 25 plus 8 is negative 17 over, and we've got that over 4 stuff. So that's what happens when we add the minus 25 over 4 plus the 2. So we get x minus 5 halves squared minus 17 over 4. All right, let's do one more here. Same kind of thing, we're going to have fractions in this. So I'm going to open up my parentheses, I'm going to make an x, and then half of positive 3 is a plus 3 over 2, 3 halves. I'm going to square that whole thing. And then we need to see what's our consequential addition. If we go 3 halves times 3 halves, that's plus 9 fourths. So I need to subtract 9 fourths as well to keep it in balance, and then bring down that minus 6. And then if I want to add the minus 9 fourths and then minus 6, 6 over 1, this is negative 9 over 4 minus something over 4. I need to go times 4, top and bottom, that's 24. Negative 9 minus 24, that's negative 33 over 4. Cool. So we can plug that in. We get x plus 3 halves, quantity squared, minus 33 over 4. And we're good. That's it. That's now in vertex form, which was our goal. I will run through those solutions. Thank you much. See you soon.